All right, welcome back, Hononegah Honors, Algebra 2. We're going to spend a second day on 4.4 factoring polynomials. When you're dividing a polynomial in the previous section, and you had examples that had a non-zero remainder, suppose the remainder was always 0. Then what would be the case? And for what would be the case with this situation? It means that it's always a factor. Think about this for a second with real numbers. If I said 5 is a factor of 45. The reason you can say that something is a factor is because when you take 45, and divide it by 5, you'll get an integer. There's no remainder, no decimal. That's what makes something a factor. So every time we talk about divided by x minus k and we end up getting a 0 for remainder, then it's just what you ended up getting when you divide it. So here we go. I'm going to be giving you some scenarios here. So this says the exact same thing. A factor theorem basically says that if you have a factor, if x minus k is a factor, if and only if you get a remainder of 0. So now I am telling you that x minus 3 is a factor. Okay, so that means it is divisible, and I know it's going to end up being a remainder of 0. So I'm going to do synthetic division because I can. That doesn't mean long division wouldn't work. But notice that I put all the coefficients and I use the opposite number when doing the synthetic division. So 1, 9, 18 with a remainder of 6. Now some of you are going to say, I accidentally messed up here, so I want to make sure to clarify this. Determine whether x minus 3 is a factor. Does it have a remainder of 0? No. So therefore, no. This is not a factor. So I apologize there. But that's what we're going to have here coming up here, is that we are going to be told that something is a factor. So this one is not a factor because ultimately it doesn't have a remainder of 0. So now, determine if this one is a factor. 2, 10, 11, -1, 6. And again, long division would work, but I'm going to do synthetic because it's faster. -3 times 2 is -6. -3 times 4 is -12, and I add. +3, and I add. -6, and I add. So determine whether or not this is a factor. The answer to that question is yes, this is a factor. Reason is because it has a remainder of 0. So now, continuing on that same, show that x plus 4 is a factor, then factor completely. So I am going to show you, I'm already told in the directions that x plus 4 will be a factor. So I already know that my remainder, when I do this, should be 0, and it is. So now they want me to take the answer and factor it again. So that's what they're asking for. Okay, show that x plus 4 is a factor, which I did, and then I take the answer and factor again. So factors of 20, that would get you -9. Would be x minus 5 and x minus 4. Show that x minus 2 is a factor. Now, many of you, and this will be on your test, but many of you will miss the fact that there's no x squared. There's 1x to the 4th, -2x cubed, and no x squared, 1x minus 2. So some of you are going to get this wrong just because you're forgetting about the fact that there's a 0 in there. Now, writing the answer, x cubed, no x squared, no x plus 1. Now, this is a perfect cube. X cubed plus 1 cubed. 1 is a perfect everything. So then the first parenthesis would be x plus 1. The second parenthesis would be first term squared. Change the sign and multiply. Always add the second one squared. So if x minus 2 is a factor, but x plus 1 and x squared minus x plus 1 are also factors. This one's going to require a graphing calculator here for just a second, but during the first 12 seconds of a roller coaster ride, the function g of t equals 2t cubed minus 19t squared plus 25t plus 42 represents the height in feet of the roller coaster after t seconds. How long is the roller coaster at or below the ground in the first 12 seconds? So I'm going to pull out a graphing calculator. I'm going to type this in. And I've already done it for you. So there it is. So you can pause this for a second and take the time to type that in. All right, welcome back. Here we go. Well, if I go to zoom standard, I'm going to see a picture that I don't really see everything. Like I can tell that there's more to this picture than what I'm seeing. So what I recommend anytime you want to see more of the picture is change your window. The window basically shows you what you see. So I'm going to make this, I'm going to go out to 20 instead. So now I'm going from negative 10 to 20 on the x-axis. And then I can tell that I want to see stuff above and below here. So I want to go up to or down to, let's say it's negative, let's go really big. Let's just see, like negative 300 all the way down and a maximum of, let's say, 100. So let's just see what that does for us. So I'm seeing a lot more of the picture, but I still need to go a little bit farther down. So again, I don't quite see it all. So I'm going to go ahead and change this to like negative, let's go like 350 then. So this should give me what I need to do, what I need to see. Ooh, really close. All right, let's go. Maybe we'll have to go all the way down to negative 400. I know some of you are wondering, whoops. Window. Oops, I accidentally changed my max instead of my min. So let's change that back to, I think it was 100. And let's go change my min to negative 400. All right, so here's the roller coaster. It goes up, it goes down, it goes up again. They want to know how long is it underground? So how long is it below the x-axis? So I want to know what the x-intercepts are. Like I want to know where the zeros are located. So I'm going to hit second, and I'm going to go to calculate, so second trace, and I want to know the zero. So I'm going to do number 2. Left bound, right bound literally is telling the calculator, I want to know what the zero is between two things. So if I go above and hit enter, so that's to the left of it, and if I go below and hit enter, that's to the right of it, and so I want to know the zero in between there. So I'm going to hit enter again. Not sure why that didn't show up, so maybe I hit something here. So to the left of it, enter, to the right of it, enter, and then enter again. So there it is, 1, 0. So it is crossing the x-axis at 1, 0. So I'm going to go back to my previous slide and write that down, 1, 0. So here's the picture, and that's 1, 0. All right, back to the graphing calculator now. I want the other one. So I'm going to hit second, calculate, another 0, number 2. And this time I'm going to go over by the other point. All right, so I'm going to hit enter. Whoops. Let's go back. Start that over again. The board is not working right now. There we go. Enter below, and then enter above. And so it's telling me that it's 10.5. So go back to my PowerPoint or my smart notebook, and this is 10.50. So how long is it below the ground? Well, it's below the ground 10.5 seconds. Notice that it was only asking for the first 12 seconds of the picture. So it was only asking from here to 12. And so when is it underground? It's underground from 1 to 10.5. So 10.5 seconds. Homework assignment is out of the book. If you have any questions, please let your teacher know, and good luck.